Good morning and welcome everybody to this month's ONA highlight. I'd like to introduce Vinicius Izquierdo. He is one of our newest PhD students in our animal science program under Dr. Moriel, and his project is going to focus on heat stress in beef cattle. So Vinicius, the floor is yours.
Thank you, Dr. Sellers. Good morning, everyone. My name is Vinicius de Souza Izquierdo. I'm a PhD student at the Animal Sciences Department under the supervision of Dr. Philipe Moriel. And today I'm gonna talk to you a little bit about the heat stress in beef cattle. So first of all, I would like to I will do a brief introduction about the subject, and then I will talk about the current challenge of mitigating heat stress in grazing systems. So after that, I will talk about the studies that we did on the last years and that we are doing here in the station right now. The heat stress, it's responsible for approximately 1.2 billion of dollars of annual losses, and it's estimated using the dairy industry and the beef and swine. So it impacts a lot the animal industry, and it's most because the heat stress compromises almost every metric of animal performance. So we should develop some strategies to mitigate the heat stress and to optimize the animal well-being. Not just the use of genetic, not just the use of breeds that are more thermotolerant, because they also suffers with the heat stress. We have to use the management and the nutrition too. The animals, when they are on heat stress conditions, they start to making some adaptations on behavior and physiology. The first thing that they do is starting for seeking for shade, reducing the physical activity and increasing the water intake. If that doesn't work, they start for increasing the respiration rates to try to mitigate the heat through breathing. They start to reducing the rumination and the feed intake. And if that doesn't work, they will have their growth, reproduction, and immunity compromised. So we have some studies with dairy cattle that showed for us that the cows that experience heat stress during the gestation, it impacts the offspring. It reduces the birth weight, it reduces the weaning weight, and it compromises the immune response. Despite of that, the offspring that is born from heat stressed cows on the gestation, they have the milk yield of the first and the second lactation impaired. Another aspect is that the daughters and the granddaughters of those cows that experience heat stress during the gestation are impacted. So it is a transgenerational effect. One aspect that we our colleagues in animal science department found in dairy cattle is that the response to the heat stress changes according to the time of life. The calves that were born of cows that experienced the heat stress during the gestation, while they are calves, they couldn't thermoregulate well. But when they are mature animals, they start to thermoregulate better than those who didn't experience this gestational heat stress. We have a lot of data that we know in dairy cattle, but unfortunately, we don't know well in beef cattle, okay? And we have to do more studies to understand that, because a lot of the studies that we have with beef cattle, it is done with Bos Taurus breeds in feedlot systems. So we have a lot of difference of our cattle here in Florida that use a lot of Bos Indicus influenced genetic. So they don't respond. They don't respond as the same as physiology and behavior as the Bos Taurus breed. And also, we cannot compare the management strategies that we do for feedlot systems with grazing systems. So basically what we can do to mitigate the heat stress in grazing systems is the use of nutrition and management. Another aspect is that we don't have yet evidence of the impacts of heat stress during the gestation on the beef progeny performance. Okay, so we don't have any results yet. Here's a picture that we happen here in South Florida every year. When we wean the heifers, they are on pastures that are flooded. So let me check. Just that are flooded. A lot of heat, a lot of humidity, a lot of mosquitoes. At the same time that it is happening with the weaned heifers, the cows are experiencing that. As you can see here, how the cows are trying to mitigate the heat stress. They don't have another way if not going to ponds. Okay, they're dealing with the heat stress the way that they can do. So, but we have to measure how is the heat stress impacting them, because you're just saying, okay, they are heat stressed, but doesn't say how much they are. It's not okay. So we have this index, that's the thermal humidity index. It's an equation that we use the environmental temperature and the relative humidity, and it gives us one number. Here I'm showing to you the data from last June to this March. And the orange line is the minimum T8I, the black line is the average T8I, and the blue line is the maximum T8I. As you can see, if I just show this to you, these three lines, you don't understand. You can make some results with this data. But when I put these two red lines, you can see if the animals are on environments below 70, means that they are on their thermoneutral zone. If they are on environmentals that is above 77, means that they are on severe heat stress. So as you can see, from June up to the end of October, beginning of November, the average T8I, it's almost all the time above this severe heat stress line. And even in December, we have some times of the day that animals are experiencing this heat stress. But we have to, what are the most important events here in Florida for beef production? In June to September, we are having the last gestation of the first calf cows. In July and August, we are weaning our cows. From August to November, we are developing the replacement heifers, and it is the late gestation of the multipurpose cows. So all this period that the animals are on heat stress conditions, it is critical for us. It impacts our points that we want here in Florida. So for that, thinking in that, we try to develop some studies to help those animals. So the first study that we developed was the Stair Steps strategy study. It was done with developing heifers. This is Stair Step strategy. What is that? It's well known in another species and in Bos Taurus breed. So instead of you giving the replacement animals a constant body weight gain, you give them a slow. They will have the gain at the start, at the beginning, a little bit slow, and at the end, you boost there, and they will achieve the final body weight. So what were our hypotheses when we thought about that? Okay, maybe we will give them the same feed amount, but they will be heavier on the end of this period, or they're gonna be with the same final body weight, but we are gonna give them less supplement. And we also thought that this strategy would match pretty well with us here in Florida. Why? Because when we are going to slow down the supplementation, it's the period that we have the higher T8I here in Florida. So if they will have less supplement intake, maybe they will have less heat increment. And if we boost the supplementation on the second part that the T8I is lower, they will have a greater supplement intake, and it may lead for the compensatory growth. So I would like to thank you, the Florida Cattlemen Enhancement Board, for funding this study. It was done on years 2019 and 2020. We did it for 2 years. We used 64 Brangus Heifers per year, assigned to 16 Bahia grass pastures, and the treatments were assigned to the pastures, and with 8 pastures per treatment per year. The control group was what we usually do here, 1.5% of body weight the entire period, from September to November, 100 days. The stair-step group, what we did, at the first 50 days of the study, we give them almost 1% of body weight. And on the second part of the study, the last 50 days, we give them almost 2% of body weight of concentrated supplementation, okay? And after day 100, all animals managed similarly, all were synchronized, all were artificially inseminated, and all received from day 100 to day 211 the concentrated supplementation at 1.5% of body weight. So the first result that we see here is that when we reduce the amount of feed during the hottest part of the study of the year, it decreased the intravaginal temperature. As you can see, during the hottest hours of the day, the intravaginal temperature was lower for the stair-step group. And when we compare the average daily gain of both groups, we didn't see any difference. So even the stair-step group receiving a third less than the control group was receiving, it didn't impact the average daily gain. So the animals, probably the animals from control group, they are leading with heat stress, and they were not using that feed to develop. When we go to the second part of the study, and we didn't see any difference in intravaginal temperature. So the animals of stair-step group, they were receiving 2% of body weight of concentrated supplementation, and it didn't increase the intravaginal temperature. And the average daily gain of those animals were greater than the control group. Even if you compare the entire study, the entire 100 days, the stair-step group gained more than the control group, with no difference in supplement offer. So they had the same feed supplementation and they gained more. It led for a final body weight greater than the control group. Okay. We didn't see, despite this heavier body weight, we didn't see any difference in percentage of pubertal heifers or percentage of heifers in estrus, or pregnancy by AI for those heifers. But when we see the final pregnancy of those heifers, the heifers from the group stair-step, they were almost 10 points higher in pregnancy rate. So this study, just changing of a constant offer of supplement for at the beginning you slow down and then boost in the end, what happened? Reduced the vaginal temperature during the heat stress and improved growth and reproductive performance of heifers without increasing feed costs. That's the main point that I want to show to you. Another study that we did, this one we started last July, sorry. It's the use of management to alleviate the heat stress of pregnant heifers. For this study, we used the artificial shade, and we use the artificial shade just because it's pretty easy for us. We have a lot of area with no shade, so we put the artificial shade. But if you have natural shade on your pastures, it works well. So we used 64 Brangus pregnant heifers on Bahia grass pastures. We assigned them to 16 Bahia grass pastures with 4 heifers per pasture. 8 pastures were with no access to shade and 8 pastures with access to artificial shade. It happened from July to day 133. That was the end of the calving season. After day 133 to day 200, all the heifers were managed similarly. All the pastures had shade. From day 200, we early weaned the calves, and we kept all the calves together for 10 days. And on day 211, we sent them to a dry lot, and we kept there for 60 days. So here is the same graph that I showed you before, but instead of showing you the time of the year, I'm showing you the time of the experiment. We ended our treatments on day 133 here. As you can see, all the period of treatment, it was heat stressing for those heifers. So the first result that I want to show to you, it's the respiration rates of that heifers. We did the respiration rates at 1 p.m. and we went to the pastures. We counted how many movements in 1 minute. And why we did that? Because the respiration rate, it has a high correlation with the body temperature. As you can see on these lines, even during the day or during the night, if the body temperature increases, the respiration rates increases. And another aspect is that we can compare accordingly to the respiration rate if they are on low, medium, high, or severe heat stress. So that's the reason that we did that. The respiration rates on day 20 and 40, they were higher for the no shade group. So the shade group could reduce the respiration rates. As you can see here, I will show you these videos in a moment. But at the first moment, I want you to see these pastures are side by side. At the same time of the day, on the same day, these videos were recorded. You can see the animals that had access to shade, they were under shade. And the animals that didn't have access to shade, they were close to the water troughs, drooling. That's the first thing that I want to show to you. And when you see the respiration rates, compare that. Compare here, compare here. A lot of difference. Same day, pasture side by side. The only difference is that one has access to shade and the other one doesn't have. So when we compare the intravaginal temperature of those animals, this intravaginal temperature was monitored for every 15 minutes during day 35 and 42. During the hottest part of the day, hottest hours of the day, the group that didn't have access to shade had higher intravaginal temperatures. And the group that had access to shade, they could keep the temperatures low. Another aspect is that on the time of the day that the TAI is not so challenging for the animals, the control group, the no shade group, had lower intravaginal temperature. Probably, we didn't evaluate that, but probably because of the behavior of those animals. They are changing something that is influencing during this time of the day that is not with hot TAI. When we evaluated the rectal temperature, we didn't see any difference on the beginning of the study, but on day 34, the animals with access to shade had higher rectal temperature. But if I just showed to you the intravaginal temperature lower for this group, why is here with rectal temperature higher? Because the rectal temperature was monitored during the morning. So that period of time that they were with higher intravaginal temperature. So it matched too. And when we analyze the body surface temperature, the same. Maybe because those animals that had access to shade, they're trying to mitigate, to dissipate the heat So they are having the body surface temperature higher than the no shade group. We didn't see any difference on Heifer body condition score on day 0 and 34, and we didn't see any difference on Heifer body weight on those days too. Okay. Now I will show to you the entire period that we collected the data. Always, except for day 126, that is end of October, the Heifers from the no shade group had higher respiration rates than the Heifers on shade group. That difference kept all the entire period that the TAI was telling the animals. When you compare the rectal temperature and the body surface temperature, the same pattern keeps going. Okay, so it's going the same way. Here is a result that is pretty good. On day 55, 125, and 202, we could see that the Heifers from no shade, they had lower body condition score than the Heifers on shade. So what means that after calving, the Heifers of shade, they were half point higher than the Heifers that didn't have access to shade. And this difference was kept up to day 202. The treatments ended here on day 133, and it was kept on day 202. We didn't see a lot of difference on Heifer body weight, but maybe because they are Heifers, we didn't shrink them before waiting, and they had different time of pregnancy. So that may be a reason that we didn't see any difference, a lot of difference in Heifer body weight. But on day 125, the Heifers of shade group, they were heavier than the control group. Okay, so as far I came, everything okay with the Heifers. Now let's analyze what it caused to the offspring. The first thing that I wanna remember you is that we didn't apply treatments for the offspring, just gestational treatments. After calving, everybody the same, no difference. At birth, the calves of shade group that the moms had access to shade were 5 pounds heavier than the no shade group. So it's a huge difference. And this increase in body weight didn't change the calves born alive and didn't change the calving date. So we have heavier calves at birth and no difference in calves born alive. When we compare the body weight at the early weaning and the beginning of the dry lot entry, the beginning of the dry lot phase, we didn't see any difference, even with the average daily gain from birth to the early weaning. No difference for those animals. We didn't see any difference on the end of the dry lot phase, despite we have almost a statistical difference, but it's not. And one of the reasons that it may be, it is because when we analyze these calves, they were not heat stressed. So the moms were heat stressed during the gestation, but the calves were not on heat stressing conditions during the evaluation period. So we didn't see any difference here too, but one that we have a numerical difference, it may be a reason. But it was a short-term study. As you can see in this picture, how it impacts in a long term the calves born from gestational heat stress calls. So how is it impacting? And for that, we are doing a study. We started last August, sorry. This study is funded by the USDA NIFA, and we are going to conduct this study for 4 years. We are going to repeat it 3 times in this period. For that, we are using 160 Brangus pregnant mature beef cows on Bahia grass pastures. And we stratified these cows in 16 pastures with 10 cows per pasture, and 8 pastures were of the control group, the group that doesn't have heat abatement strategy, no access to artificial shade, and 8 pastures are of the heat stress abatement strategy. So they have all the cows of this group have unlimited access to artificial shade with an area of 40 square feet per animal. These treatments are from July to November, the same that happened with another study. After calving, all animals managed similarly, all pastures with shade. So this way we'll go up to the next weaning, and on the next weaning we are gonna get the heifers that were born of this study and stratify them according to the gestational treatment. So half of the heifers that were in control group during the gestational phase will be in control group on the post-weaning phase, and half will be in the heat stress abatement strategy. And the same will happen with the heifers that were in gestational heat stress abatement strategy. So in this study, it's a long term, and we are really excited to evaluate. We are going to have a lot of microbiology data, a lot of metabolomics, genomics to analyze and try to understand what are the effects of gestational heat stress on the offspring in a long-term perspective. So I would like to thank you for watching me today. If you have any questions, you are watching through Zoom, you can insert the question on the box. If you have any questions here, I will be really happy to answer that. Thank you. I have a question here. In the second study, if you didn't see any impact on the offspring's performance, why do we recommend the heat abatement strategy for pregnant heifers? It's a pretty good question, thank you. One point, we didn't see any difference on the offspring, but one, or probably the most important point of this study is that the heifers that were on shade environments, they had half of a point more than the heifers that didn't have excess shade. To have this difference, we have to feed the heifers 200 pounds in this period. So you are not spending money feeding or time feeding those heifers. You are just putting shade, and they are being with a better condition score than the others that were not. Mm-hmm. Okay. The question is if this heat stress that is happening, how it impacts the cow-calf pair, if it changes the behavior of feeding and how they are together, right? We have some studies that show that the heat stress changed the way that but these studies are in feedlot that change the behavior and how they sort the particles of feed. So we have this difference in feedlot. In grazing systems, it's a little bit hard to see this difference and to evaluate that. But we also know that the milk production of that heifers, it's coming from dairy, not in beefy. The milk production is impacted, so the quality will be impaired because of the heat, and the calf can have the performance impaired because of that. Thank you.
Thank you, Vinicius. That was a very good presentation. Just a couple announcements for those of you that are still online and in the room. Our field day, youth field day, is next Thursday already. It flew up on us quick. And for those of you that have attended our webinars religiously, we do have a couple more coming up next month on July 12th. It'll be a webinar by David Mason. He's a PhD student in the Wildlife Ecology and Conservation Department under Dr. Marcus Lashley. And he's going to be talking about fire, and his title is Fire Generates Seed Rain via the Magnet Effect. So I'm kind of curious what that title even means. So join us next month for that. And then August 9th, our new president of the Florida Cattlemen's Association will be here, Wes Carlton. He's going to discuss current and issues and initiatives of the Cattlemen's Association. So that ends our seminar today, and we appreciate you attending. Have a good day.